in this section we are going to discuss the closure property of binary operation. So the definition is written here already. Let star be an operator on the set G. G could be any set of real numbers, rational numbers, integer numbers, or natural numbers, and this was shown to you in the previous video. So here we have A star B, and when this operation is done we get an element. And what is the closure property here? So this answer, or this element, the creation of the new element, should be also an element of G. So you can say that G is closed under the operation star. So if you do an operation of elements that are from G, then the answer, the element that you get as an answer, should be also an element of G. That's called the closure property. Let's do an example that will make it more clear for you. So here, let's take a question that says, is the set G equals to integer numbers Z closed under closed under operation star given by A star B is equal to A minus 5B. So we're given the operation, and we have to see the set G, which is a set of integers. Is it closed under this operation here? So now to prove a satisfying case, like here you can see, if you just look into it, that this would generally satisfy this, because if you have two numbers and you just subtract the numbers with multiplying 5 to the other number here, the answer would also be an integer, right? Because if you're taking two integers and subtracting them just by multiplying a whole number and another integer to the integer b, the answer would also be an integer. So it would be a part of the integers, the set of integers z. So if you can see, first analyze it, and you can see that this is or you can say this is satisfying. In that case, you have to prove using general terms. So in general, you have to prove it. So how do we do that? You can say is, let's say the answer is, so here we have A is an integer times, an integer B would be equal to an integer A minus 5 times an integer. So 5 times an integer will again be an integer, and an integer minus an integer will be an integer. Okay, so generally we have proved that yes, this is satisfying. So this the set is, you can say, is closed under the operation star. So you can write here, therefore yes, set G equal to the integer number Z is closed under operation star. given by A star B equal to A minus 5 times B, because for all A comma B an element of G, or you can say an element of Z, A star B is also an element of Z. Alright, so you can, let me read it again. So the set G is equal to Z is closed under the operation star given by A star B is equal to A minus 5B is because for all AB which is an element of Z, the A star B operation is also an element of Z. Okay, I hope that's clear. This was for a satisfying case. You have to prove it like this. Now let's take a case which is not satisfying maybe. So that's a second question. And here we have, is the set G equal to natural numbers closed under operation star given by A star B is equal to A minus 5 times B. So we're taking the same operation here now again, and we'll check whether this is closed under the operation of star or not. So now generally if you look at it, natural numbers are without zeros and non-negative numbers. Only positive numbers and positive integers are natural numbers, right? So if generally if you look at it, you can see that there can be some numbers that if you subtract 5 times the number B, which may be smaller than A, or even if it's the same, if you 5 times the number B and you subtract it from A, you will get a negative number. So in that case, the negative number will not belong to the natural numbers anymore, right? So in such a case where you can see it or analyze it that this is not closed under the operation star, so the answer is not a part of the set G. In that case, you don't prove it generally, you prove using a particular example. So let's say it now here. The answer is no. This is not closed under the operation star because let's take two numbers. For A, let's say 2, and for B, let's take 3. So here you have 2 minus 5 times 3, which is equal to 2 minus 15, that would be equal to minus 13, and that is, or you can say that is not an element of natural numbers, right? So therefore, for all A comma B an element of natural number, A star B is not an element of natural numbers. So that's the proof. Now let's go ahead and do more examples for this. Let's take a third example. And here we have, is the set, okay, my handwriting is a bit hard to understand maybe. So is the set G an element of, is a set of G which are elements of the natural numbers closed under the operation star given by A star B is equal to A divided by B. So what do you see here generally? If you have any two numbers and you divide them, like something that's not giving you a proper integer as the answer, if you divide them, in that case that won't be an element of natural numbers, right? So if you have, let's say, 4 divided by 2, so for A you took 4 and for B you took 2, 4 divided by 2 would be 2 and that would be an element of natural numbers. That satisfies. But what if we take some other number, let's say 10 divided by 3, we don't get a proper natural number, right? We get a decimal number or a fractional number. So then this is not satisfying. The answer will not be an element of natural numbers. Okay, so again the answer is no here, and that we would prove it by a particular example. So let's say the answer is no, because let's take an example. So 5 times 3 is equal to 5 over 3, and that's not an element of natural numbers, right? So this is not closed under the operation A star B. Now we can go ahead and do more examples. Let's go and do example 4. For same operation like question 3, let's say A star B is equal to A over B. Check. For set G is equal to integer numbers now. So first we had natural numbers here, and now we do the same thing, but we change the set G to integer numbers, and we see if this operation, the elements that we get at the end of the result here, A divided by B, does it belong to the set of integers or not. So here again the answer would be no, because if you have some fractions here, fractions are not set of integers. So now we could have negative numbers or positive numbers, but we cannot have a decimal number. So A divided by B could easily turn into a decimal number, so that wouldn't even still belong to the integers, right? So still we would have no for the answer maybe. So we can say answer is no, because let's take two numbers. For A minus 3 times B is 2. So we have minus 3 divided by 2, and that is not an element of integer. That's not an integer, right? Minus 3 divided by 2 would be minus 1.5. That's not an integer. So yes, then the answer is no for that. we can go ahead and do more examples now. So I hope it's becoming clearer with more examples. So for example 5, for the same operation again, a star b is equal to a divided by b. Check for set g now equal to rational numbers, right? So here we have to take two elements a and b, and we have, if you divide a divided by b, is the answer also a element of the rational numbers? Now what's the thing that you have to follow for rational numbers, right? So for rational numbers, the element b cannot be a 0 when you divide a divided by 0 here. This one here cannot be a 0. Okay, now that's not kind of prohibited in the question, so we could take a equal to any number, let's say 5, and if we take b equal to 0, then this is not satisfying. The answer a divided by b will not be a part of the set g, which are rational numbers, right? So the answer will again be a no. So the answer is no, because five star 0 is equal to 5 divided by 0, which is not an element of rational numbers. Okay, now let's go ahead and solve one last example to make it clear for you, which is example 6. So for the same operation, a star b is equal to a divided by b. Check for g, now a set of rational numbers again, excluding 0. So you cannot have 0 now, neither for a, neither for b. In this case, you know that this will be true, right? Because in the previous case, we could only say that it is not true, or it is not coming under the closure property, because q was in q rational numbers, we could choose the number 0. So if we chose b is equal to 0, then the answer would not be a part of the rational numbers, so it is not closed under the property now, or closed on the operation. But then here we are saying that the rational numbers, the set g is set of rational numbers excluding 0, so 0 is not included in this set now, set g. So for this case, yes, if we cannot choose the number b as 0, in that case any fractions are elements of the rational numbers, right? So the answer for this particular one will be yes. So the answer here is yes, it is closed under the operation. So here we can say yes, because for all a comma b an element of rational numbers, a star b is an element of rational numbers. Alright, so if we take now a and b from here, from the set of rational numbers excluding 0, then the a star b is also always, which is a star b, what I mean is this one here, a divided by b, right, the operation. So a divided by b will always be an element of the rational numbers. And that's the end of this section.